the S3 upper outboard PAS deploy. This will be the future house for one of the express logistics carriers that is being launched on the STS-129 mission later on this year. This is located out on the outboard side of the S3 truss module. Both crew will translate out there, and there are some structural beams which they will have to remove out of the way to allow the PAS structure to be deployed. These beams provide structural rigidity to the truss structure when they're installed. With those out of the way, then a platform and yoke assembly is pulled up out of the truss. Once that is cleared, it allows those structural attachment beams to be resecured into their fasteners to regain the structural integrity of the truss. With those two beams back in place, the crew then resecures the platform and the yoke assembly onto some clevis brackets on the longeron of the truss itself. These are the same type of carriers that experienced problems during the STS-115 mission where it was stuck in a detent. We have some tools to override that if we experience the same difficulty in our mission. After that is complete, the crew is going to go and replace that rate gyro assembly that I showed a picture of earlier. Christopher Fuglesang will enter the inside of the truss on the S0 side. He'll work on the box from that side. Meanwhile, Danny Olivas will be on the aft side of the truss where there is a thermal blanket which will be pulled back, exposing the box. When that thermal blanket is removed, he will have access to the box inside, and he'll be able to see Krister, and they'll both be able to work on the release of the bolts. When he gets to the work site, the first thing he's going to need to do is temporarily stow the replacement box outside on a handrail above the work site. This is brought to the work site in a thermal bag to protect it prior to its installation and activation. Here you can see that thermal cover being removed, exposing both Krister and the rate gyro assembly. That has 4 bolts and 2 electrical connectors which are disconnected as it slides out of a track and is temp stowed out of the way. The replacement rate gyro assembly is installed on these tracks. Danny will fasten the aft 2 bolts, and Krister will get the forward 2 bolts. When that is complete, Danny will retrieve the failed box and bring it back inside and stow it inside the airlock. With that complete, our next task is to have the crew split up a little bit. Danny Olivas will be working on connecting some heater cables on the PMA-3 module. Connecting these heaters allows that vestibule and that PMA to be pressurized such that the IV crew can outfit it in preparation for the Node 3 module to be delivered on the STS-130 mission. With that heater cable connected, at the same time, Christopher Fuglesang will be working on replacing a remote power control module assembly up on the S0 truss. This RPCM, as it's called, has experienced a minor failure, and so we're going to replace it, put a new box in its spot. As part of replacing this box, there are a series of power downs which are required to protect the crew, to make sure that they aren't disconnecting any powered electrical connectors. So there'll be a lot of coordination between the ground control team and the crew on orbit to make sure that those power downs go smoothly. With that box replaced, we're going to take advantage of the fact that we have all these inhibits in place to install a insulating sleeve on an exposed ungrounded connector inside the truss. So with those inhibits in place, Christopher Fuglesang will enter the truss through an access port on the aft side, install one of these insulating sleeves, and then exit the truss. With that task complete, the hard door, which had been previously powered down, can be reactivated. While the crew goes on with their next task, they'll join up together on the port side of the Node 1 module, and the remainder of the EVA will be focused basically on deploying 2 60-foot-long cable bundles. This will be routing power from the starboard side of the S0 truss module out to the port side of the Node 1 module, and this is basically providing power and data for the upcoming Node 3 that will be launched on the STS-130 mission early next year. These cables, as I said, are 60 foot long and definitely present a challenge to the crew in terms of managing them. They can get to be a bit like a bundle of snakes. So we have a good plan in place for how to route these and how to secure them. They'll basically be using some copper wire ties to secure these onto handrails along structure. They'll leave a coil bundled on the aft end of Node 1, and the STS-130 crew will be able to take that bundle and connect it to the Node 3 module once it's installed, and that'll provide, as I said, the power and data to that module. We can see how this cable is routed, as I said, from the aft port side of node 1 along the node structure. It goes back in between the S0 and the Z1 truss structure over an area we call the rat's nest, where it will get plugged into an avionics panel through a series of 4 connectors to the S0 truss. In addition to this one cable, there is a second cable bundle as well, which provides redundant power and data to the previous bundle that we're installing. This cable bundle will be installed on a similar spot on S0, right next to the panels there that you can see there, for an additional 4 connectors. Then this cable will be routed out across the lab out to the airlock. In order to visualize where this cable is routed along the structure, I think it'll be useful to remove the airlock here so you can get a clear indication of where this is going. This next cable bundle will utilize the bag which was previously stowed outside on EVA2. And again, that cable will be routed down between the lab and the external stowage platform number 2, head along out to the node 1 module beneath where the airlock is, to the aft end cone of the node 1 module where we'll go under that side, and then be coiled next to the bundle that was left out there earlier in this EVA. Once that cable is secured and stowed down, one of the big things we need to make sure we do is bias as much of the slack within this cable towards the coiled end. We'd hate to have the 130 crew get up there and find that they don't have enough slack in this cable and they're going to have to redo all the work we've done. So we have a plan in place to lay it down once in a sort of loose configuration, then go back and readjust these wire ties and bias all the slack towards the far end so that the future crew has as much play in this cable to make that connection as possible. From that point, Olivas has a slide wire which was installed in the STS-88 mission that can be removed. We'll be bringing that inside. That causes interference with the Node 3 module, so we need to get that out of the way. Additionally, Christopher Fuglesang will be installing a lens cover on the SSRMS camera. This lens cover is highly desired for the upcoming HTV launch. In the event that there is an aborted rendezvous, we want to make sure that the thruster jets on that HTV do not plume the sensitive optics on these cameras, and we retain the optical integrity of these cameras. So this lens cover will basically protect that surface during that rendezvous operation. That will finish out our EVA 3 and all the EVAs on this mission. As I said, it should be a good challenging mission between the mass handling of the ammonia tank, the utilization of the science and the retrieval of the science experiment carriers, and the handling and the preparation for the Node 3 module coming up on a future mission.